can see me on the left and on the right. For me, it's been the snap of a finger. And I'd show you a picture of me in the future, but you wouldn't believe it. So, the reality of the universe is the mathematical result of all the sentient beings in it. I was talking with Dr. Ed Close last year, and he had written a wonderful book called Transcendental Physics. And during the interview, we discovered that there are literally almost 7 billion realities on the earth. Each one of us has a perspective of reality. This is an exploration into how that reality gets created, and the realization that we are 100% responsible for that reality. We are having these effects through a quantized process we call observation. And that takes place whether we are awake, whether we are asleep, whether we are conscious or whether we're unconscious, and some people are just not conscious, they're conscious. Whether we're loving, and especially whether we're fearful. In all of these conditions, we are affecting the universe. And they're doing it, and we're doing it, whether we realize it or not. And the universe is the result of that. Now, in physics right now, we are still wrestling with the theory of everything. A method of understanding not only quantum physics, but also astrophysics, the very small and the very large. Because the rules, although we know the 4 great forces in the universe, gravity has wonderful effects on heavenly bodies, but almost no effect on atoms and protons and electrons until it gets very, very intense. So, one of the things that they've left out of this equation, up until recently, is the consciousness constant. What we realize when we look at the universe is that we have a very simple formula. Mass over volume equals density. We call it grams per cubic centimeter. This is the amount of weight that you can fit into a given area. But a strange thing happens when we begin applying consciousness and imagination to this. We come to a question in physics. Einstein laid it out for us in his theory of relativity, which we'll discuss in a little more detail here shortly. But the limit is light, sort of like sound was the speed limit in air, until we figured out how to compress air inside of a can, throw fuel to it, and shove it out the back end in a jet that pushed us past the speed of sound. But is light really the speed limit of the universe? Actually, thought is the fastest thing in the universe, many times faster than the speed of light. Physics begins to undergo some asymptotic changes. That is to say, as we approach the speed of light, time begins to slow down. Now, time is also part of that equation. Because when we think about the speed of light, 186,000 miles per second distance per time, or 300,000 meters per second, it's the second that changes as we approach the speed of light. It slows down. And when you throw that into the equation, you get infinity. That is to say, distance equals 0, and time equals 0. And when Dr. Close and I were talking, I said, well, let me ask you a question, Ed. What does the universe look like from the perspective of the photon? Forget about being in an elevator next to a light beam traveling through space. Let's be the photon for a moment. Let's say that we are traveling across space and time as a photon. What does it look like? He said, well, actually, it's all right now. There is no distance. There is no path between one point and another. When we think about space itself, when we go out and do the night watches here, we have a nice definition for it in science. It's void. with the presence of particles or energy. Well, that's pretty clear-cut, isn't it? Void with the presence of particles or energy. But if I were to take you to the edge of the universe, I mean the very edge of the universe, where there's a wall or a curtain, what would you do? You want to part the curtain, you want to look over the wall, right? Into the void. But when you do that, you have just created more space. Because now the energy of your thought, the energy of your consciousness, your imagination, has just entered that void. And by the definition of space, you have just created more space. Well, that's a very basic observation, although mathematically very sound. So let's think about the universe in terms of mathematics here, just very quickly, not anything really advanced. A couple of ways of looking at it. One is the Lagrangian. This allows us to describe the complete motion of a system. It's sort of the lazy universe. If you look at the two dotted lines up here, you'll notice one is following the curvature of the bottom of curved spacetime quite neatly. It's actually the lowest possible energy state, the lowest allowable energy state. That's the Lagrangian. The one above it requires more input. It requires energy to be put into the system. It requires some concentration of energy or some consciousness to be put into it. Systems don't follow this form. The Lagrangian is the kinetic energy of the universe minus the potential energy of the universe. And the interesting thing about this, when we look at the arrangement of planets, this is exactly what we see. The Lagrange point is the point at which there's no movement between two heavenly bodies. And interesting to note that the Lagrangian of the Earth compared to the Sun is not the center of the Earth. That's right. It lacks about 2,000 kilometers. It's slightly off-center, which is another support for hollow Earth theory, which we'll cover another time. Now, the Hamiltonian is another way of looking at the universe. If you buy the big, thick black book called Gravitation, you can read about this. But it's very similar, except different. In this, we take the kinetic energy and we add it to the potential energy of the universe. Well, when we do this, we get a strange effect. We get a closed system expressed in terms of momentum, position, and time. That's the way we look at our universe. This is relativity. We locate everything in the universe relative to everything else in the universe. That's relativity. And that presents a point of imagination. Even great minds have put thought into, what does this mean? What letters do we put in what sequence to understand what this relationship is? And Einstein was great in putting together and formulating an application of relativity for us. He didn't think of it, but he did organize it and did make it presentable to us. What we end up with is what we call a closed loop universe, a general covariance. Everything in the universe is located by everything else in the universe. How far is it from the Earth? How far is it from Alpha Centauri? How far is it from the center of the galaxy? Our galaxy from another galaxy. But that assumes that there's nothing outside our universe. Hence, it is impossible to determine the location of the universe. Because we're inside the universe, and we're using everything inside the universe as our frame of reference. And it limits us in our imagination. And humans don't like to be limited in their imagination. On page 457 in that big black book, Gravitation, the Hamiltonian of the universe is 0. That means if you add the potential energy and the kinetic energy of the universe, they zero out. It proves that the universe is finite. All times are equally real. There is no special now. No distinction between past and future. In fact, past and present do not exist. And movement of time is considered to be just an illusion of human perception. Well, I said, Ed, I have a problem here. I guess you're telling me that there are about 6.5 billion different realities on the Earth, and then what we perceive as the Earth and life is just an average of all those perceptions of reality. He said, that's correct. That's a good observation. Well, if that's the case, then with such a large population of 6.5 billion, close to 7 billion sentient beings on the earth right now, the average will be very stable. Even if we enlighten a few, it's not going to make a very big difference in the mean, unless those who are awake speak to others, and they awaken, and others, and they awaken. Now you have a mathematical equation, a mathematical completion of a sampling that allows the average consciousness, the average reality of this universe to shift. And that is a reality. That's the power of being able to remember the future. This is the book Gravitation. You should buy one, because they're really neat, thick, 2,000-page book that you can put on your coffee table, and when people walk in, they will think you're really smart. Especially if you can say, no, if you look on page 457, it says the Hamiltonian of the universe is 0. Wow. And there's something else in the book. There's a picture. And this is how they explain how the universe is expanding. It's a balloon. And on the balloon are little dots representing galaxies. And the universe is inflating, so all the galaxies are moving away from every other galaxy. There is no center of the universe. There's no point at which there's a big bang and everything is moving uniformly away from that point, which also is a big argument among astrophysicists right now. Even though Big Bang is fairly well accepted as a given, it's by far not proven. The big question we ask when we look at this in the book Gravitation is, who is she? Who's blowing up the universe? And when the universe deflates again, where does that go? This gets the imagination into the thoughts of eternity. What does eternity look like? Does it look like this Mobius tube? Does it look like a curvature of space-time, one eternal round? Is it a quantum foam twisting and turning in space with all kinds of potentials of probabilities? Or is it the way religions look at it? If you died today, where would you spend eternity? When I see this, I go, wait a minute. Like, aren't we already in it? Like, somewhere in the middle? Why do I have to die to get to eternity? Didn't I come from it? Haven't I been alive for eons? And now I'm having a mortal experience as an eternal being? It sort of shakes the dogma of religion. I'm not saying spirituality, far from it. I'm saying religion. Here's the big question. What if there are other universes? What if they're like probability bubbles in the void, inside of which are whole other sets of galaxies and whole other sets of clusters of galaxies and superclusters of galaxies? And when we think about this as physicists, we go, you know, we have to think about this from a probability point of view. What are the odds that we would have a universe like ours, carbon-based, with stars putting out nitrogen and carbon and oxygen and silicon and elements like this? What are the odds that we would have protons and neutrons like we have in our universe? And they do some calculations. Gee, it has to be a trillion to 1. We're a very rare universe. But such is not the case. Because star after star after star that we look at, they're all putting out the same elements. In fact, if you vary the frequency of a star a fraction of a percent, thousandths of a percent, the star doesn't function. It doesn't even light up. It turns out that there is a golden mean for this to occur. Like phi, 1.618 to 1, which we will explain in a moment. It is irrefutable. It is a law to which all universes must comply. Therefore, all universes only form like this universe. Any other pattern becomes so chaotic that it can never take form. It fights itself like like a train wreck, and it can never become organized, like dropping an egg on the floor. It just can't reconstitute itself into an egg. The probability is not there. So if there are these multiple time spheres, do they transfer information between themselves? We have recently theorized and have a fair amount of empirical data. We're looking for some more using the laser interferometer gravitational wave observatories. LIGO for short, L-I-G-O. There's actually one in Washington State up in Hanford. There's another one in Louisiana, another one in Australia, and they're in the process of launching another one called LISA, which is a laser interferometer space antenna. Interferometry is the science of taking a laser beam and making it interfere with itself by splitting the beam and bringing it back together 90 degrees out of phase so that you get zero signal. It totally cancels itself out. Now when you think about it, it sounds pretty easy. Mathematically it is, but controlling the stability of the wavelength of that laser, making sure you have perfectly clean mirrors, making sure there's no terrestrial vibrations to shake the mechanics of it, to make that signal as quiet as possible, has been a real challenge. Why are there 3 LIGOs on the Earth? Because they're so sensitive, they can detect a vibration a fraction of a proton. So if a truck drives by, or a minor earth tremor, or a lightning strike, or a wave crashing on the shore, at 1 LIGO, the odds are it's not going to occur at the other 2. So when they're all online together, those anomalous signals are tuned out. Only the signals that occur at all 3 simultaneously are legitimate. Now why interferometry? Because the laser beams end up being about 20,000 miles long by the time they bounce back and forth between the mirrors of that instrument. A 20,000 mile long ruler is pretty sensitive. The theory is that when a gravitational wave comes through our neck of the woods, space-time ripples. Sort of like taking a sheet and giving it a shake, or dropping a pebble in a pond. You see the wave propagate out. When that happens, the odds of all 3 LIGOs responding in exactly the same way is 0. They're all going to respond differently because they're on a round ball. So you have one looking this way, and one looking that way, and one looking this way. So the effect is that we get a triangulation. And when there's a gravitational event in the universe, we can then locate its spot. It works with coalescing neutron stars as they come together in space, very heavy, dense collapsed stars, because we can validate it with our radio antennas. We have yet to directly detect a black hole. That's the challenge. That's what they're trying to do. This year or next year, they plan on directly detecting a black hole. So, when we think about these universes, and the fact that there may be information transferring between them, great thinkers like Dr. Kip Thorne or Stephen Hawking realize that there are probabilities of what we call virtual particles appearing and then annihilating each other. Well, the odds were that right at the event horizon of a black hole, if 2 virtual particles were to appear, sometimes one of them will get sucked into the black hole and one of them will radiate out. Identical information that's being duplicated on either side of an event horizon. If there's any truth to the theory that that black hole is actually a window, like that balloon connected to another balloon who happens to be deflated, and you squish one balloon and the other balloon inflates, that information goes back and forth between those universes. If it goes back and forth between the universes, if this information really does do that, odds are it's going to be highly concentrated along the gravitational lines of that black hole. And it just so happens in 2012, our planet is about, our solar system is about to pass through that plane. As we near it, the probability that we are exposed to that information from another universe, from another time, or left behind from our universe increases. And we're now being exposed to more and more information. If we look very close, the true potential of the human spirit is made known. All of space-time can be viewed as being laid out as an unchanging four-dimensional block. I know right off you can't see the four dimensions in here, but you got the inside, the outside, and then you have the spiral energy that goes around the filaments of the universe, and it gets mathematically pretty easy to look at. The idea is that there's no now moving through time, and if there was a now, we would have no idea how fast it moves through space, because all this speed is relative. Now, this created kind of a conundrum for us as we were having this discussion, because if this is true, then that means that when we look out into space, we're really not looking back in time. We're really not looking back to the collapse of stars or a past star out there radiating. It is independent of time. When you look out at the Pleiades, 440 light years away. By the way, just by a show of hands, are there anybody Pleiadians here? I thought so. I got that, yeah. When you look out at that, you realize, oh my goodness, 440 years it took for that photon to reach my eye. And it gets kind of daunting when you swing a Dobsonian scope around it and get a view like this. It can take your breath away. It's so gorgeous, it's so beautiful. All the beauty of this arrangement, and imagining the planets that are hanging around there, dozens and dozens of worlds. But the truth is a little stranger than that. When you look at Sirius in the sky, by the way, I'll tell you just a little short story here because it's in the book and it's in my past, and I thought that I would go ahead and share it with you. On the left of your screen, you see Sirius. We call it Sirius A. This is the Sirius that Egypt was aligned to, the pyramids in Egypt. This is the Sirius that heralds the flooding of the Nile. This is the Sirius that we see in the night sky. But behind it, there are three other stars. There's, of course, Altair, Deneb, and Vega, but in between that is a little tiny white dwarf called Sirius B. That's what we call it. Around Sirius B, before it went red giant, there were other small stars, suns around which planets revolved. 2,000 years ago, it was recorded that this area was red in appearance. That would have meant that the sun went red giant, but please, 2,000 years, it should still be red. Unless, and this was a big argument in physics for a long time, how could the ancients have looked at Sirius and seen a red glow in the same neighborhood? Because if that red sun was there then, it should be there now. 2,000 years is a cosmic microsecond. But in actuality, something else happened. On one of those planets around that once sun is where I came from. In my dreams, in my meditation, this is the terrace on the edge of my house that overlooks, and you can see the red sun in the background. This is what my hand looked like. 5 fingers and a thumb. 4 joints in each finger. And this is what the sun looked like. And when it went red giant, it consumed that planet. I walked out on that deck one day and woke up here in the body of a 9-year-old boy. Turns out, a physicist recently at MIT theorized that there's a small black hole in the neighborhood of Sirius B. And that black hole stripped the corona off that sun. In just a few hundred years, it turned into the white dwarf that is left behind. Sirius B is in the neighborhood. By the way, how many Syrians do we have in the room? Very good, 8.6 light years away. So that's what happened now, in between Vega and Deneb. Back to the photon. When you look into space and you see the photons coming at you, you see them with your eye and you realize that you're looking into the past. You're really not. Because at the speed of the photon, it is instantaneous. It doesn't take that photon 8.6 light years to get here from Sirius. It gets here now. Because at the speed of light, time slows down to nothing. In fact, we can validate this as gravity curves space-time, which only exists at the speed of mortality, by the way. We get information from these photons. Here's what we learn. When we look at hot photons, we get sort of a rainbow of energy from that. When we put atoms in front of that hot signal, they absorb some of that light. We call this an absorption spectrum. And we can very precisely identify atoms by this absorption spectrum. In fact, there's a catalog of those absorptions. And atoms in front of hot objects absorb these colors, and this is what it looks like. So, we can also tell precise elements by these spectra and fast Fourier transforms of that spectra. We can also tell if a star is moving away from us. This is the spectra of a star not moving away from us. And you can tell the difference between that and a star that is moving away from us because the lines are shifted longer. We call it a redshift. It's still the same spectrum. It's just stretched out because the star is moving away from us. We can also tell if the star is rotating. If it's not rotating, it makes a nice clean absorption. If it is rotating, it scatters that absorption. So we are getting information and we're learning to interpret it. But the interesting thing is that as the photon leaves its origin, it arrives here at Earth, bounces off your face and into my eye, and both the photon and I have joy in that, because I get to see you. But what if we look at this from the perspective of the photon instead of our perspective? And this is going to be key. What we realize is there's no path between Sirius and here. There's no path between the Pleiades and here. It's instantaneous. Like the baseball leaving the pitcher's arm and arriving at home plate. Believe me, there's no hope of hitting this ball. As soon as he releases it, it's in the catcher's glove. There's no path. There's no way to track it. But if that's the case, how is it that we see time progress? It's because it's human consciousness that has created time. What does the universe look like? As we approach the speed of light, time slows down, finally to zero. Is it black? No. What we realize is that the entire universe is still the singularity. In a Heisenberg uncertainty, we realize it is consciousness that has created time. We sped the universe back up. We're the ones that took it from singularity to what we see right now. Not just the few that are here on this planet either. But why? Why would we do such a thing? Why would we take it from everything now, everything at our reach, all knowledge, omniscience, to this? So that we could fall in love, so that we could create one another in our own image, so that we could savor the flavor of a good meal, of a glass of wine, of a sunset. We would know what it is like to swim in water or to fly in the air or to listen to music and to discover new things. Discovery is impossible if you know everything. Our consciousness has created the universe. The realization is, and it's a shock, especially to astrophysicists, the Big Bang never happened. It's only our observation that has made the universe what it is right now. It's only our perspective of realities that has made it what it is right now. Well, just a minute. Doesn't that mean that I created this mess? Doesn't it mean that I am responsible for the lack of abundance in my life? I am responsible for the frustrations and degradations of my life? Yes, it does. And you created it. But I want to change it. Okay, that's good. That's a start. It is human consciousness that creates time and allows each intelligence to savor itself. So, just some quick definitions. A spectrometer is an electronic instrument capable of detecting small levels of energy precisely and accurately. There will be a test later. The human body, I call a biological transducer, capable of detecting small levels of energy precisely and accurately. That's true. We have ears. When we're young, they worked very well. This one and this one are, okay, we won't go into that. But we can pick up sound vibrations and analyze them, speech and music. We can identify our location in the universe. We have eyes, amazing spectral photometers that can pick up color and black and white images. Together, they work stereographically to give us depth perception. They allow us to track things through space and interpret our universe. But this is a very, very narrow band of radiation that we pick up with our eyes. Anything infrared, wavelengths too long for our eyes to see, or ultraviolet, wavelengths too short for our eyes to see, are invisible to us. That doesn't mean they don't exist. As we refine our technology, or as we discover other ways of sensing those frequencies, the realities begin to come to us. We have skin that can pick up all kinds of texture. We have tongues and noses, which are amazing olfactory and chemical spectrometers that can detect saltiness, bitterness, sweetness, sourness. If it weren't so, we would all be eating what? Saltine crackers and oatmeal. I mean, we want wonderful flavors. We like to stimulate our biological transducer. That's part of the beauty of being mortal. Now, awakening is the turning on and the tuning in of the human body to the fact that it carries an eternal being within it. Believe me, you see a lot of people walking around. I mean, they're breathing and stuff, but they're not awake. I see some on the freeway, and it's pretty scary. I meet some at work. We call them wallpaper. You've been here 20 years? You see them too. You're not with them because you're here. So you're awake. The key is to remember. Okay? Part of discovery is wonderful, but if you discover that all you really have to do is reach back in your memories, you realize that the entire universe is already folded up inside of you. All of these mysteries are already known to you. Now the game, the challenge, the purpose of life is not to remember everything, because then where's the excitement of life? Besides, you wouldn't be able to relate to us. So you got to be just a little bit ahead of yourself and a little bit behind the curve so that you can maintain the excitement of life. How do you do this? How do you gain this? Because life is pretty noisy. Life is pretty fast. I mean, it's economic, right? I run out of money before I run out of month. There are realities to life. Or are there? Very good. Well, in the workshop that goes along with this, we talk about meditation. Most of you meditate, or at least are trying to learn meditation. This is good. To get quiet enough from the world so that you can pick up the energies of these realities is important. because there's a discovery that was made in putting this book together. All known physical principles, from Newtonian mechanics to Einstein's relativity, have completely symmetric treatment of past and future. That is to say, it's just as far from here to Portland as it is from Portland to here. Okay, I know you don't believe that. It is a lot further from Portland to here than it is from here to Portland. Okay. Nowhere in any of these equations is there anything which distinguishes a forward direction of time from a backward direction of time. Mathematically, we just can't evaluate that. And yet I know that if I drop that egg on the floor, it goes from the present to the future. It ain't coming back. It's not equal. And there are other great minds that have thought about this. And they had an aha moment. The exception to this rule appears to be quantum mechanics. Whenever we make a measurement of quantum observable, this is very small, there is a collapse of the wave function, in which a probability wave collapses to generate a single observed value from a range of possible values. On the one hand, you have the potential of all potentialities, and on the other hand, you have the choice that you made. It gets interesting, because 94% of the universe is not visible to us because it's in the wave function. We call it now dark energy and dark matter, but really this is kind of arrogant for us to say this. Just because we can't see it with our instruments and our eyes, it's dark. Maybe it's super bright and we just can't see it. Maybe it's actually the subconscious of the universe. And the universe is actually about 5% conscious. And that's what we pick up. Ah, that consciousness constant. I love it. So, whenever two people, or two thoughts, or two photons come together in wave function, they interact with one another. We call this an interference pattern. Like two pebbles dropped in a pond, the waves come together, and they either cancel each other out, or they double each other, or somewhere in between. We call this the observation effect. How our interaction with other wave functions have a mathematical result. Unobserved photons act like waves. When we look at the photons, they act like particles. This man right here, Thomas Young, was a physician, and he was fascinated with taking cadavers apart, dead bodies. And he became really fascinated with the human eye. And as he became fascinated with that, he developed light experiments, where he would take a single point of light, which you see at the top of the picture, and shine it through a single slit, generating, like one pebble dropped in the pond, a set of waves. He would then run that through two slots, giving it two possibilities to pass through, and guess what? Double the waves. And when the waves began to collide with one another on the other side of the screen, they canceled each other out or accented each other, just like you see on the bottom of it. Light and dark bands. Constructive interference building itself up, and destructive interference wiping itself out or annihilating itself. This became critical in understanding how these things come together, how they interact in the universe, and why we are an important unknown variable in this equation. The truth is, even in instrumental analysis, when we use remote sensing or sense enhancement to observe a sample, we don't really see what's really there. This is a pollen particle used or seen with an electron microscope. Now we just bombard the heck out of the thing with electrons, and what bounces back gives us this image. But is this really the pollen particle? No, not really. I mean, we slightly altered it, right, by bombarding it with electrons. We have this observation effect whether we want to or whether we do not. The use of a biological transducer to observe a sample does exactly the same thing. It's easy for us Well, let me take that back. Sometimes it's not so easy to recall the past. When we talk about the past time cone and the future time cone, in this drawing they look pretty symmetrical. And we pretty much think that it is past and future. I mean, I looked at that high school photograph of myself and a recent photograph of myself. That's pretty symmetrical. If I stood in the middle and looked to the future and looked to the past, then maybe it isn't. Here's the interesting thing. Okay, we're going to talk about STD. Oh, it's the second law of thermodynamics. Come on. Entropy increases with time. Disorder. Things just naturally come apart. Cars get old. Okay? That's the second law of thermodynamics. Except at the origin of the universe. This is Roger Penrose's first diagram about this. He suggests that we would expect time, reversed path, to be symmetrical with time future. That's the CABV that you see right there. Time would be just as symmetrical going A to B as it would from A to C. But that's not really the case, because as we go back toward the beginning of the universe, we see a much higher set of order. We can't go back there. We can't reorganize the egg we dropped on the floor. We went from higher order to lower order, and there's no going back. Sir Roger Penrose, a Brit to be sure, he says consciousness is the result of quantum gravity. I disagree. I say quantum gravity is the result of consciousness. It is actually consciousness that collapses wave functions into solid matter. And I think this is what Sir Roger Penrose's office looks like. In the Department of Entropy. But that's just from a Scots point of view. Time, this paradox that we look at in the future. Starting with source point, the potential of all potentialities extends for eternity. We speak to our teenagers when they listen, and we tell them that they have the whole world laying at their feet. They can be anything they want to be. All they got to do is choose. Of course, we've kicked ourselves out of that equation. Now our life's already done. There's nothing we can do. But your life, it's just laying before you. You can be anything you want to be, the potential of all potentialities. But in reality, if you look at this denominator, this is pi times the diameter squared times the height of the cone divided by 12. The denominator changes. What happens is that radius, the result of that cone begins to change, and it becomes parabolic. In fact, we get all kinds of undulations in that potential of all potentialities. How do we do that? Well, we do that by pushing our own future threads into that cone. We decide how the universe is going to unfold and deliver us what we want, what we dream about. Unfortunately, like those other universes that might be based on some other element, it doesn't resonate. There's no mathematical probability for that to occur. So if you want to accomplish a dream, you've got to leave the probability at its maximum. Access to time by human observation is very possible. Like in the movie Next with Nicolas Cage. In the very beginning of the movie, he's narrating it, and he says, basically, I can look 2 minutes and 20 seconds into the future. But the future changes just because you looked at it. Ha, it does. A very strange thing happens. It changes structure. It changes motion. Considering a condition in time is observing it. And when we observe it, we change the function. We change the probability. Observing it has a change upon it. There can be a change in entropy toward order. How does that happen if you have a universe in explosion? Well, you can take a segment of it and you can observe it and you can change it. This is what I think time lays out like. From left to right, we have the past. You'll notice it's not just a little straight line with no dimension to it. It's kind of a thin tube, which means we have some latitude with what we can do with the past, inside of reason. I mean, we can't replace that finger we lost. I didn't actually lose finger, but we also can't uncrash the car. We can't unburn the house, but we can change how it affects us. We can change how we move forward with that reality. So here we are in the present. You'll notice going forward too, the cone isn't that great wide potential of all potentialities. It's somewhat truncated. That's because of the choices we've already made. That's because of your choice not to go to college, or your choice to marry this person, or take that job, or buy that car. All of those choices affect your immediate future. But out beyond that, it's pretty much the potential of all potentialities. The trick is to shorten that front cone and try to open it all the way up. How do we do that? How does that work? We go to the past and we look at things, we can change them, which changes the present as well. I use this slide because it reminds me of a story of two people sitting outside in a cafe having a small meal, and all of a sudden in the street beside of them, two cars have an accident. Neither one of the drivers are hurt, but they're piling out of the car, and both the drivers have a different version of what's going on. The policeman shows up to write his police report, gets their stories, looks over at the sidewalk and sees the two people having this small meal, and asks, "Did you see what happened?" "Well, yeah, I mean, we were sitting right here." So he gets their reports as well. Now how many versions of the crash does he have? 4. Just about that time, the restaurant owner comes out and says, "Hey, I have a surveillance camera that overlooks this area. We could go watch the tape and see actually what happened." So the policeman says, "That's an excellent idea." So the 6 of them go into the observation room, the store owner plays the tape back, and everybody gets to view the event objectively, just the way it unfolded. And the one driver says, "Oh, you're right, I crossed the line when I dropped my lipstick in my coffee." And the other guy says, no, it was my fault for not reacting quick enough. I was reading the paper.